Okay, Algebra 1 students, in this video today we will be learning how to multiply and divide. And hold on one second, my mimeopad is not working. There we go. It does help if you turn it on, and I just turned it on and now we're good to go. Alright, in this video today we'll be learning how to multiply and divide numbers that are written in scientific notation. Okay, that's what we're going to do today. Multiply and divide numbers that are written in scientific notation. Please write your heading down. If I go too fast, just pause the video, okay? Here we go. Multiplying and dividing scientific notation numbers. Lesson 8.4 Part 2. And be sure to include today's date. Alright. Now, learning how to multiply and divide numbers that are written in scientific notation is really important, and it saves a lot of time. You could take two numbers that are written in scientific notation, rewrite them in decimal form, which would take some time to do that, then multiply or divide them, get your answer, and then rewrite your answer back into scientific notation. Now that's not super hard, but it's definitely longer than what we need to do, because there is a much faster way, and that is what we're going to look at today. Alright, so here we go. Please take great notes, please pay close attention. This is a very simple lesson today. It's not difficult at all. It's a very short lesson, but pay attention and you should be fine. Let's start off by looking at how to multiply numbers together that are written in scientific notation. Okay, so we're going to start off with multiplication first. I would like you to write this sentence in your notes. Please copy this down. Now again, if I go too fast, just pause the video. When multiplying numbers that are written in scientific notation, you listen carefully. Multiply the first parts of each number. Then write the number 10 for your base and add the exponents. Please copy that down, and then I'm going to show you exactly what I mean. And I think you'll find this really, guys, pretty simple. Okay? Alright, here we go. Please copy this problem in your notes, students, if you would. Write down 1.2 times 10 to the negative 9th. Again, if I go too fast, just pause the video. Times 1.3 times 10 to the fourth power. Okay, now, obviously, this parentheses here and this parentheses here, they're side by side. You could put a dot here if you want to. These two numbers are multiplying, okay? So yes, like I said earlier back here, you could take the two numbers, rewrite them in decimal form, then multiply them, then write your answer back in the scientific notation. That's going to take a lot of time. So I want to teach you a shortcut, and I hope you'll take some really, really good notes, okay? When multiplying numbers that are written inside the scientific notation, what do you do first, students? Are you looking? Watch, please. You multiply the first parts of each number. So, what's the first part of this number here? 1.2. What's the first part of this number over here? 1.3. What do you do to those two numbers? You multiply them. Got it? So if I take 1.2 times 1.3, you'll get 1.46. Trust me, you can use a calculator if you want to, or you can do the long multiplication, but you will get 1.46. So I take the first number, the first part, times the first part, and I get this. Is that easy? Take this times this, piece of cake. What do you do next? You write the number 10 for your base. So you write the number 10, and what do you do to the exponents? You add them. Negative 9, positive 4, add them, and what do you get? Negative 5, and you're finished. Now guys, that is fast, that is easy. So when you're multiplying numbers that are written in scientific notation, multiply the first part. So you take this times this, and you put that right here, okay? Then you write the number 10 for your base, always the number 10, and then add the exponents. Now, is this answer right here in scientific notation? If it's not, then you want to fix Is it written in scientific notation? Let's see if it is. First of all, do I have one digit to the left of the decimal? Yes, a 1. I have a 1 to the left of the decimal, so I'm good there. Do I have a 10 here? Yes. Do I have a whole number here? Yes, I'm good. This is written in scientific notation. I'm finished. Are you listening, guys? Whenever you multiply two numbers together that are written in scientific notation, you want your final answer to be in scientific notation also, okay? Alright, let's try another problem. Please don't zone out. This one's a little more difficult, so please pay attention. Alright, here we go. Let's say I gave you 4.1 times 10 to the, I'm not sure, 7th power. Alright, and I put squared right here. So I've got a scientific notation number being squared. Well, guys, you know what that means. If you have 4 squared, that means write the 4 how many times? Twice, right? So if you have a scientific notation number squared, it just means write that number twice. That's all that it means. It's not that difficult, okay? So we simply write the number twice. That's easy, isn't it? Sure it is. And now here we go. Let's finish this up. We're multiplying two numbers that are written in scientific notation. Well, if you look at the steps here that I've given you, I've told you that the first thing you want to do is you want to take the first part of each number, this part here, and this part here, and you multiply them together, okay? So 4.1 times 4.1 is 16.81. Alright. And then you write your 10. And then you add your exponent. 7 plus 7 is 14. Please don't put 49. You do not multiply the exponents. You add them. Now most of you probably worked ahead. You're probably done. And you thought you were finished. You are not finished. Because your answer is not written in scientific notation. It looks like it is, but it's not. How many digits do I have to the left of the decimal? 2. How many do I want? 1. So you're going to have to move the decimal one place to here. So now you have 1.681 times 10. Now, we're either going to add 1 to the 14, or we're going to subtract 1 because we moved the decimal one place. Okay, now think about it. Think about it like this, guys. If I had a really big number like 5 million, and I was writing that in scientific notation, I would take the decimal and I would move it all the way to here. And your exponent would be what? Do you remember? It would be positive. So when you're writing a number in scientific notation, when you go from the right to the left, your exponent's going to be positive. So because we're going from the right to the left, we're going to add 1, not subtract 1. So my answer would be 15. Let me go over that again. Because I moved it from the right to the left in scientific notation, I'm going to add 1, not subtract 1. So there is your final answer. Every year on test and quizzes, students, every year students forget to check their answer, and they think that they're finished because they get this answer here and they think it's in scientific notation. Okay? Well, it's not, because you have 2 digits, the 1 and the 6, to the left of the decimal. Remember, a number is never written in true scientific notation unless you have 1 number to the left of the decimal. Okay? That's the only examples I'm giving you for multiplying numbers that are written in scientific notation. It's really simple. Multiply the first parts, write a 10, and add your exponents, okay? Now, let's finish this up by dividing numbers that are written in scientific notation. I would like you to write this sentence in your notes, please. Now pause the video, that's fine. When dividing numbers that are written in scientific notation, and by the way, as you read this sentence and write it down, you're going to notice it's the complete opposite of when you multiply numbers that are written in scientific notation. When dividing numbers that are written in scientific notation, you divide, not multiply, you divide the first parts. Then you write the number 10 for your base and you subtract, not add, you subtract the exponents. So it's the complete opposite of when you're multiplying scientific notation numbers. Okay, now I'm going to move on. If you need more time to copy this, I'll just pause the video. Now, let's try a couple of these, okay? So here we go. Let's say I have 1.3 times 10 to the 5th power divided by 1.2 times 10 to the, I don't know, 7th power. Okay? Now, I have a scientific notation number here, a scientific notation number here. So I divide the first parts. So here's the first part. Here's the first part. So with my calculator, I type in 1.3 divided by 1.2. And when I do that, I'm going to get, and by the way, it is the top divided by the bottom. So 1.3 divided by 1.2. 1.3 divided by 1.2. And when you type that to your calculator, you will get this right here. You will get 1.083333 repeating, okay? So it's okay to round. I'm going to simply put 1.083. That's good enough. If you want to put a bar here, you can. You don't have to. It's up to you. So we take the first parts of each number and we divide them. Then we write the number 10 for your base. And then we subtract the exponents. It's always the top minus the bottom. So my top number is 5 minus the bottom number, which is 7, negative 2. And there we go. Okay. Now, pretty simple, guys. We know we're finished because this answer is written in proper scientific notation. I have a 10 here, a whole number here, a times sign here, and I have one digit, a 1. I have one digit to the left of the decimal. Okay? And that's what I want. So we are finished with that problem. Let's try one more, and we're done for the day, okay? Please take really good notes on this last problem. Alright, let's go with 1.2 times 10 to the negative 13th power over 4.8 times 10 to the negative 8th power. Alright, now notice I'm dividing two numbers that are written in scientific notation. So the first thing I do is I divide the first parts. So here's my first part. Here's my first part. With my calculator, I type in 1.2 divided by 4.8, and I will get 0.25. The next thing I do is I write the number 10 for my base, and then I subtract my exponents. Now remember, it's the top exponent, negative 13, minus the bottom exponent. So be careful, minus a negative or a double negative just makes it become positive. So negative 13 plus 8 or negative 13 positive 8 gives you a negative 5. Now a lot of you probably thought you were done and you circled your answer, but hold it. Notice your answer is not written in proper scientific notation. Yes, we have a time sign. Yes, we have a 10. Yes, we have a whole number here, but this decimal should be here. Because right now, do we have any numbers? Do we have any digits to the left of the decimal? Well, you can put a 0 there. Remember what I've taught you. Zeros don't count when we're talking about having one digit to the left of the decimal. So right now, do we have a digit to the left of the decimal? No, we don't. So we want to move this decimal to here. Okay? So then we would have a 2 to the left of the decimal. So if we move the decimal from here to here, I would have 2.5 times place. Well, think about this, guys. If I had something like 0.00063, and I asked you to write that in scientific notation, you would move the decimal from the left to the right to right here, and that would be a negative exponent. We learned this in your last video, okay? Moving the decimal from left to the right when you're writing a number in scientific notation is a negative exponential move, okay? So I am going from left to right, so I am going to add to this 5 a negative 1. So I have a negative 5 and a negative 1. When you add them together, you get a negative 6. Okay? That's it, guys. I know I'm finished because my final answer is in proper scientific notation. I hope this video has been a help to you. If you have any questions at all, don't hesitate to call or email. And you should be able to, when you're done with your homework today, you should be able to